Hey, what's going on? I wanted to make a test review video for our derivative and limit test, 2-1 through 2-3. Let's get started. So on this first problem right here, it says describe the x values for which the function is differentiable. Explain your reasoning. All right, for this problem right here, x squared minus 9. I know in your paper it might say x squared minus 16, guys. That's a mistake. Given the answers, you'll understand why. Because 1, 2, 3, 1, 2, 3, right? If I were to solve that, x squared minus 9 equals 0. You add 3 over, and then square root both sides. You get x is or not equal plus or minus 3. All right, x is not equal. All right. Anyway. You'll see that, guys, you get 3 right there, which is 3 and negative 3. All right, anywho, so if you look right here, you'll see where you have two cusps. All right, you have a cusp right here at negative 3, and you have a cusp right here at 3. All right, we have a cusp at x equals negative 3 and 3 cusp. All right, that takes care of the describe portion. So where is this undefined then? All right, we're going to say negative infinity to negative 3, right? And then we're good right here between negative 3 to 3. And then union 3 to positive infinity, like that, all right? All right, number 2 right here. Notice we have a gap. All right, there's a gap. Whoa, sorry about that. There's a gap right here. All right, there's a gap at 3 specifically. 1, 2, 3. There's a gap at 3. Gap at x equals 3. So how is this defined? All right, well, we're going to say, I'm sorry, I keep saying define, I mean differentiable. All right, we're going to say x, or let's say negative infinity to 3 and 3 to positive infinity. All right, because right there at 3, there's a gap. All right, then this last one right here, let's use the vertical line test. All right, right there. That's a bad spot, but we can adjust it right there. All right, so you notice this line touches multiple parts. Man, no cooperation right here from this thing. All right. So, all right, vertical line. I use the vertical line test right here. All right, and instead of using the black one, I think we can see it. So see how that touches multiple times? All right, it's not differential at that space, all right, which is 1, 2, 3, negative 3. All right, so we got to define that then, okay? And how do we define that? We're going to say the vertical line test, all right, vertical line test at x equals negative 3. All right, so we have negative infinity to negative 3, union, negative 3, positive infinity. All right. All right, cool. Right here it says find the derivative of the function. Be sure to use the correct notation. So we're going to use the power rule right here. All right, so let's find the derivative of x, right, with respect to x. So right here, we're going to do 5 times negative 7 is negative 35. And then we subtract the 5 by 1, so that's x to the 4th. Then we're going to do 4 times 1, because there's an implied 1 right here. So that's 4. And then we subtract that 4 by 1, which is 3. And then we're going to do 3 times 8, which is going to be a negative 24. That's negative 8, so negative 24. And then reduce that 3 by 1. And then this is the constant, and the derivative of the constant, guys, is a constant. So there we go right there. All right. This is the derivative. All right, for this one right here, we have, oh, don't forget your indicator, guys, that you're taking the derivative. That prime right there is our indicator. Okay, right here, we're first going to rewrite this. All right, so let's start by rewriting it as h of x equals negative 5x to the 1/2. All right, we want to have that exponent. Now, we take the derivative as we did over here. We're going to multiply this 1/2, all right, to this negative 5. So that gives us h prime of x, or the derivative with respect to x, is going to be negative 5 here. Let me write this out so y'all can see it, times 1/2. And then we need to do x to the 1/2 minus 1/2. It's the same thing we did over here. I'm just writing this out so you can see it. And not 1/2 minus 1/2. My apologies, 1/2 minus 1. Alright. So if you remember real quick, getting common denominators, I'm going to address this first. Alright. Well, you have 1, but you know 1 is the same thing as 1 over 1. So if I need a common denominator of 2, I'm going to multiply this by 2 and this by 2, right? So that gives me 1/2 minus 2 over 2, because that's 1, right? So that gives me a negative 1/2, all right? Don't be lazy. Please practice, all right? So we end up with x to the negative 1/2. Now, last thing I want to address is multiplying a whole number. 5 is 5 over 1. Negative 5 is negative 5 over 1 times 1/2. Well, you multiply the numerator and you multiply the denominator. So negative 5 halves. So the derivative right here is going to be negative 5 halves x to the negative 1/2. All right, now we got to fix this. We don't want to have a negative exponent. So we can move that x and this exponent to the bottom. Therefore, it's positive. Like that. All right, now it's a positive because I use the reciprocal property. And last thing I'm going to do is I'm going to write it as a radical, because remember 1/2 we converted from this, so I'm going to write it back as a radical. So there is our final answer. All right, that is the derivative of number 2. All right, I'll move the answer up here. Now, all right, for this next one right here, we have negative 3x to the 1/5. So what we're going to do here is we're going to multiply this one. We're going to multiply negative 3 by 1/5. All right, so we're going to have, oops, that's y inverse. We don't want that. We want y prime. All right, the derivative equals negative 3 times 1/5. And I'm writing this one all the way out just so you can see it. X raised to the 1/5 minus 1. All right. So instead of 1, I'm just going to put 5 over 5 because that's 1. You see it? So anyway, right here, you get negative 3 over 5 x. And right here, 1 minus 5 is negative 4. Negative 4/5. Now we got to rationalize this. All right, we don't want to have the negative exponent. So remember, we move the negative exponent to the bottom. 4/5. And now, lastly, I just want to turn that back into a radical. So doing so, that's negative 3 over 5 to the 5th root of x to the 4th. Right there. All right. All right, over here. Let's see, let's go to another color. All right, we need to rewrite this. First of all, we're going to rewrite g of x as 1 over 2x to the negative 2nd. Alright. And then we're going to take the derivative. So g prime of x. Alright, we're going to multiply 2 to the negative 1. I mean to the 1, so that's negative 2 over 2x, and then we subtract 1, so that's negative 3. Now, negative 2 over 2, guys, because negative 2 times 1 is negative 2. That's negative 1. So, here, let's just do it like this. Negative, that's negative 1, so negative x to the negative 3, which we can then rewrite as negative 1 over x cubed. Alright, because again, the negative exponent goes to the bottom, like that. And the negative is just negative 1, guys. Remember, there's a negative 1 right here. That's negative 1. Alright, keeping it going.
Students and staff.
Alright, this one. Alright, okay. We're going to multiply right here. So that's a positive. So I gotta change that width, it's too wide. Positive 6b subtract 1 negative cube. Minus 14b to the first. So this one we rewrite as 6 over b cubed. Alright. Minus 14b. There's your derivative right there. Right here, okay. Let's rewrite y. So y equals negative 3x to the 4th times x to the 5th, like that. And now we're going to combine these first. Alright, the reason we combine them is because it's multiplication. We can multiply that. Alright, so that's going to give us multiplication. That's that. So negative 3 times 1 is negative 3. And remember, you add the powers when you multiply. So x to the 9th. And now we take the derivative. So that's negative 27 x to the 8th. There we go. Alright, let's keep it going. Man, derivatives. Alright. Wait a minute, this was not written. Alright, I had to rewrite this problem because it wasn't correct on here, but here we go. A couple different ways you could do this. Personally, I think we could rewrite it. Alright, so if we rewrite it, we're gonna have f of x equals negative 3x to the 4th plus x squared minus x plus 3. Alright, and then I'm going to bring x squared to the top, so x to the negative 2nd. And I'm going to write this exponent 1 right here so you can remember when you multiply, you end up with, you add the exponent. So I'm going to distribute x to the negative 2 to all of these. So I end up with negative 3x times x to the negative 2nd. Remember, you add the exponents. So you get negative 3x squared, 2 plus a negative 2 is 2. 4 plus a negative 2 is 2, sorry. Right here you have x squared times x to the negative 2. Well, 2 minus 2 is going to be x to the 0. Alright. I'm going to come back to that. That's important. Right here you have negative x to the 1st and x to the negative 2. So negative x 1 minus 2 is going to be a negative 1. And 3 times x to the negative 2nd is positive 3x to the negative 2. Now, this right here, remember x to the anything to the 0 power is 1. So I'm going to rewrite this one more time. like that. Now I'm going to take the derivative. All right. So for the derivative here, we're going to multiply this out front. All right, that gives us a negative 6x to the first. The derivative of a constant is 0. All right. Right here, negative 1 times negative x is positive x, but you got to subtract 1. And distribute that. It's going to be a negative 6x, and then subtract 1 negative cube. Alright, and now we just need to fix a couple things, and we will be alright. Let's condense this. Negative 6x to the first, plus x to the negative second, minus 6x to the negative third. So when we write these, we're going to get negative 6x plus 1 over x squared minus 6 over x cubed. And voila, there you go. That's the derivative right there of this equation. And now there's one more problem on the front side, number 11. Again, distribute. All right, so it's going to be negative, actually that's positive 36x. Remember, add those, so x to the 6. And then there's going to be a positive 12x squared. Now we distribute. So we get 6 times 36 is 216x, and subtract 1. So that's 5. And then right here, 12 times 2 is 24. And subtract 1 is just x to the first. Alright, right here it says suppose the function g of t represents a test grade out of 100 points as the function of hours studied. If g of t equals this function, alright, points, what is the derivative? This means dg over dt is the derivative when t is 5. Alright, right here, answer to the nearest point per hour. Alright, I think that's simple enough. So let's dig in. We take our equation and we first need to find the derivative of it. Okay, it says what is the derivative when t is 5? So we need to find the derivative first. So we're going to multiply by 3 up front. So that gives us negative 3. Well, here, let's do it. 3 times 0.048 is 0.144. So negative 0.144 t squared, because you got to subtract 1. And then right here we're going to multiply 2 times 0.925, which is going to give us 1.85 t to the first, and then that's a constant. So we have g prime of t equal to negative 0.144 t squared plus 1.85 t. Now we need to evaluate g prime of 5, all right, because t is 5. So we just substitute it in to our equation right here. 0.144 times 5 squared plus 1.85 times 5. All right, when we do that, it gives us a whopping 1.85 times 5. 5.65. All right, it says round your decimal to the nearest point, so 5 points, right? You see that? 6 points, sorry. Oh yeah, and since it says the function of hour studied, so 6 points per hour. All right. Now, for this one, the variable cost of manufacturing tricycles is 8.55 per unit. So that's important. All right, just reading this. 8.55 5 per unit. So per unit, we're going to represent as X. We don't know what that unit is yet. Okay. And then it says it has a fixed cost of 600. So write a cost C as a function. Write the cost C. So C equals 8.55x, because we don't know what per unit is. All right, and then we know the fixed cost is 600. So there's our equation. Now, anyway, it says find the derivative of the cost of the function. All right, so find the derivative. So this is 1. So 1 times 0.855 is 8.55. Nope. Well, if you subtract 1, it's 0. So just 0.855. We're not going to write it out. 8.55. And the derivative of a constant is a constant. So there we go. There's our equation right there. Now, for this next one, it says suppose the height S in feet, so S is the height, at time t in seconds of a $6 dropped off the top of a mountain. Stone Mountain is given by S equals -16t squared plus 1,686. Find the velocity of the dollar when it hits the ground, round to the nearest decimal. So look, listen, it says it hits the ground, which means the height, S equals 0. All right, S is 0. So what we do is we go, we're going to set the height equal to 0 then. So 0, because S is 0 at the ground, equals -16t squared plus 1,686. Now, the reason I did that again is because S is 0, right? It's at the ground. So S is 0 for this equation. So now I can find the time it took to get to the ground. So what I do is I'm going to add over 16t squared to both sides. So if I add 16t over here, 0 plus 16t squared is 16t squared, right? 86. And then we're going to divide both sides by 16. So I get t squared equals 105.375. And then we're going to square root both sides. I get t equals 10.277. So I know what t is now. Now, the second part of this question says find the velocity. Find the velocity. Well, when I find velocity, guys, I have to take the derivative. All right, velocity equals derivative. This equals derivative. All right. So I take the derivative of this equation right here. So I'm going to do it right here. Multiply 2 right here. That's -32t. S prime equals -32t. And the derivative of a constant is a constant. So there's my velocity equation. All right. That's my equation I'm going to use. Now I just need to substitute my value in for t. I know what t is. All right, so S of t equals -32t. And if I plug in 10.27, all right, I'm going to get -30. 328.6. Is it feet? Feet and feet. So feet per second. So this thing falls 328.6 feet per second. All right, 15. It says find an equation of the tangent line. All right, find an equation of a tangent line. So I can tell you right now. Let me erase this. When you can find an equation of a tangent line, you're going to use point slope form. Meaning y minus y1 equals m times x minus x1. So first of all, I need to find the slope. And how do I find the slope? Well, no, I don't need to find the slope on this one. Well, no, we need to find the derivative. That's what we need to do, find the derivative, sorry. So I'm going to go y prime equals 5 times 2 is 10 x to the 4th. All right, plus 4 times 1 is 4 x cubed, and then a constant is a constant. All right, so there's our derivative. Now that I have my derivative, I need to plug in my x value. All right, so I need to evaluate this. All right, for -2. So I have 10 times -2 to the fourth plus 4 times -2 cubed. All right, so 2 times 2 times 2 times 2 is 16. So I get 10 times 16. All right, and right here, -2 cubed is -8. So that's 160 minus 32, which is going to give me a total of 128. Now, this, guys, is M. Here's our slope. Yeah, find your slope. So take the derivative of your function, plug in your x value, all right, to find your slope. Once I have my slope, I use point slope formula, which I wrote down up here. So we do y minus y1. Well, guys, there's my y1. So I'm going to go plus 55. And the reason I'm doing plus 55 is because it's a negative 55. So if it's y minus y1, minus y1. So negative and negative becomes a positive. All right, equals m, which is 128, times x minus, all right, x minus x1, which is plus. So plus 2. All right. And then if you like, you can condense it. Okay, or you can leave it like this. So I'm going to leave it like that. This is our equation right here. Production. But remember, right, tangent line is at an instantaneous point. All right, use that. All right, tangent, instantaneous. And if it's instantaneous, remember, you want to take the derivative. All right. All right, for this one. Okay, cool. Let's do this one. So we have x squared plus 3 squared. We should definitely start by fooling that. Okay. So later y'all will learn how to take the derivative of that. But anyway, no, x squared plus 3 squared, we need a foil. So that's going to be x to the fourth, and then plus 3x squared plus 3x squared plus 9, which gives us x to the fourth plus 6x squared plus 9. So there's our function. Now we're going to find the derivative. Alright, so this will give us 4x cubed. This will give me 12x. And derivative constant's a constant. So now remember, we got to plug in our x value. So that's 0. H of 0. H prime of 0. Alright, so that's 0 times 0 is 0. Alright, and 0 times 12 is 0. So it equals 0. So this is my slope. There's no slope. Alright, so now I just plug it in. Y minus y1 equals 0 times x plus 0. So anyway, 0 times all of this is still 0. So I have y minus 9 equals 0. Add 9 over. Y equals 9. There's my equation right there. Alright, for the 16. Alright, 2 more. 17. It says find the average rate of change on the interval. Find the instantaneous rate of change at the endpoints of the interval. All right, cool. So average rate of change, first you got to find the slope. So what I need to do is I need to first evaluate the original equation for these two x values. And remember, guys, let me erase this so I can have space to talk about this. Hey, by the way, if y'all need those other problems, just rewind. That's the cool thing about YouTube. Remember, this is where this problem starts. That's the first x value. This is where the problem ends. All right, but it's x2. That's the second x value. All right. So first I'm going to evaluate for f of negative 4, meaning 3 times negative 4 squared minus 5 times negative 4 plus 8. So that's going to give me 16. 16 times 3 is 48. And plus 20 plus 8 gives me 6876. This one, so for this one right here, guys, we got this point right here. Negative 476. That's our first coordinate point. For the other one, h of 2, we have 3 times 2 squared minus 5 times 2 plus 8, which gives me 4 times 3 is 12 minus 10 plus 8. So 2, 10, right? That gives us 10. So we have the point 2, negative 2. No, it's 2, it's positive 2. So those are my 2 points. So for the average rate of change, guys, listen, we just plugged in our start point and end point, got our 2 y values, made our corresponding coordinate points, and then we're going to use the slope formula, which is y2 minus y1 all over x2 minus x1. So we do 10 minus 76 all over 2 minus a negative 4. All right. So 10 minus 76 is a negative 66. And this right here becomes a plus, right? So that's 6, which becomes a negative 11. So the average rate of change right here is negative 11. Average rate of change. Now that we have that, we can go over here and find our instantaneous rate. Instantaneous rates. And remember, with instantaneous, you must take the derivative. Take the derivative. Alright? So if we take the original equation and take the derivative, 2 times 3 is 9. And we have x to the first. Right here you have a 1. So 1 times negative 5 is negative 5. And 1 minus 1 is 0. So, and then the derivative of a constant is a constant. So here's our, is it h? Yeah, h. H prime of x. There's our derivative. So, why'd I put 9? Guys, 2 times 3 is 6. I so am tripping. So let me rewrite that. 6x minus 5. There's our derivative right there. 6x minus 5. Sorry about that. Holy crap. Now, I have that. Now all I do is I evaluate, not f, I evaluate h prime of x for my corresponding values, which is negative 4. Man. Which is 6 times negative 4 minus 5, which is negative 24 minus 5, which is going to be a negative 29. And then h prime of 2, which is 6 times 2 minus 5, which is 12 minus 5, is going to be 7. All right, these 2 rates right here that we just solved for, this one and this one, are the instantaneous. All right. Okay. One more problem. Last problem. Again, to find the average rate, remember first you're going to plug in your value. So we have, whoa, where you going? You have f of 1 That's your start. That's where you end. So 1 to the 5 halves is still 1. And then we have 4, f of 4 to the 5 halves. Oops, f of 4 equals 4 to the 5 halves. So now, if you remember, guys, this can be written. Remember, your denominator is your root. So square root of 4 to the 5th power. Well, the square root of 4 is 2. All right, so 2 to the 5th. All right, and 2 to the 5th is going to be 32. So we have point 1, 1, and 4, 32. So now that we got that, guys, we can find our slope by going y2 minus y1 all over x2 minus x1. And that gives us 31 over 3. All right, so there's our slope, which is our average right here, average rate of change. Now I got to find my instantaneous rate. And to do that, we've got to take the derivative of our function. So we take the derivative of this, we end up with 5 over 2x. But remember, you got to subtract 1. So 5 halves minus 2 over 2, because that's 1, right? It's going to be 3 halves. All right, so 3 halves. Now we find f prime of 1. Remember, we plug our x values back in. Find the instantaneous rate, which equals 5 halves. And f prime of 4, our other x value, which is 5 halves times 4 to the 3 halves, which again, I'm going to write this as 5 halves times the square root of 4 cubed. So the square root of 4 is 2, and we cube it. So that's 5 halves times 8, which becomes 40 over 2, which is 20. So those right there are our two instantaneous rates. Instantaneous. All right. Anyway, I really hope this helps. I know it got kind of long, but hey, I wanted to be thorough. And good luck on your test tomorrow. Peace.